Today in this short presentation video, I'd like to discuss leak path identification and how Lumeta can help organizations reveal unauthorized connections between your network and other networks or subnets. Leaks can allow traffic to bypass security provisions into and out of your network and create unsafe passageways, leaving you vulnerable to attacks by worms, viruses, and other hacker activities. Lumeta's detection of leak paths are a unique feature that allows organizations to be alerted to network paths and connections that inadvertently give hackers access to network-sensitive data. The two major causes of network leak paths are unauthorized network connectivity and risky network connections. Unauthorized network connectivity can include unknown networks and devices, unsecured or unknown partner connections, unauthorized DSL or cable modems, and unsecured wireless access points. Risky network connections can include device misconfigurations such as firewalls, router and VPN concentrators, dual home devices, and modem devices. The way in which leak path identification works is that it identifies forwarding and filtering devices, enabling IT staffs to assure these resources are in compliance with security policies. Flags inbound and outbound connectivity to secure zones such as those developed to protect customer data or carry sensitive communications, as well as spots hard-to-find leaks such as unauthorized cable or DSL routers, multi-home servers, and NAT/PAT proxies that covertly forward network traffic. Lumeta defines a leak as any unauthorized connection from one host to another. Lumeta uses specifically modified packets to determine outbound leaks. After host discovery is performed and leak identification has been selected, Lumeta uses the collected host information to test for leaks. A leak sensor is placed in a network to which connectivity is to be tested, most commonly to and from the Internet. Lumeta uses the address from discovered host as a starting point for discovering leaks. Outbound leak identification uses the IP address of an external leak sensor as the spoof source address. If a host can respond to this spoofed address, the host is considered leaking. Inbound leak identification uses the same methodology as outbound leak detection, except for the role of the spoofing sensor is reversed. The external sensor is passed an internal IP address collected during host discovery via SSL, and the external sensor uses them as the source address for testing connectivity inbound. Leak path identification options. The recommended protocols and port numbers are those that are allowed by most ACLs. The DNS discovery attempts to perform a lookup for the local host. If port 53 is used for the UDP option, standard UDP responses should be expected. If the port is running, there will be a positive acknowledgement that will be recorded. If it is closed, an ICMP port unreachable message will be recorded. When using these options, be aware that they will only check routers and address spaces that are beyond the internal scan server's perimeter. That's the end of our presentation today. Thank you for listening. For more of our videos, please visit our YouTube channel at the following URL.